Okay, so in this video, what we're trying to do is take a look at function notation and see how we can expand on it a little bit to perform operations. And by operations, we mean primarily add, subtract, multiply, and divide. But later, you're going to see a new operation called composition. So let's get started with add, subtract, multiply, and divide. All right, if I gave you this function right here, I'm sorry, these expressions right here, and I said simplify each of these expressions. This is something that you've seen already, and I just want to remind you how to do it. So if I asked you to add together two polynomials, okay, I would just add together the like parts. So I would look for other x cubes, and in this case I don't see one, so I would just write down x cubed. I would look for other x squareds, and in this case the only other x squared I have is 5x squared. Okay. I can add together 5x plus negative 4x, and that's just positive 1x, and 12 plus negative 14 is a negative 2. Right, so this is just combining like terms. Right, when I do subtraction, it's the same thing. We just have to be a little bit more careful. 5x squared, I don't see any other x squareds in the problem. Right, so that's just going to get written down. Okay. I'm going to say negative 4x minus 5x. Well, negative 4 minus 5 is negative 9x. 14 minus 12, well, that's 2. Okay, and then I can't forget about this x cubed. I haven't done any x cubes yet, so this x cubed is going to be a negative x cubed because we're saying minus x cubed. So at the beginning of this, just to keep it in standard form, I'm going to say negative x cubed. So again, this is stuff that you've done already. All right, and then your last one, if I'm multiplying together a binomial and a trinomial, we're just going to multiply everything out. So we're going to get 5x cubed minus 4x squared plus 14x. Okay, and then I'm going to do the same thing with the 10, and I'm going to say this is now plus 50x squared minus 40x plus 140. And then our job is just to combine like terms, so it's 5x cubed, and then negative 4x squared plus 50x squared would be plus 46x squared. 14 minus 40 is minus 26x plus 140, right? So this is exactly what you've been doing for years, that you started in Algebra 1, add, subtract, multiply with polynomials, right? So the only thing that we're changing is how I ask you to do these things. So if you take a look at the new setup here, right, I'm giving you those three expressions, f of x, g of x, and h of x, and if you take a look back at our last problem, right, the only three things that I use, like if I take a look at my f of x, that was x cubed plus 5x plus 12, right, that's actually this first expression here, and if you notice, it's showing up in a lot of my problems, right? My g of x is 5x squared minus 4x minus 14. We use that already as well, right? Here it is. It's in all three of my problems, okay? So we used these three functions, okay, in our last problem that we solved them, and I'm just asking you to do adding together the functions a little differently. So I'm saying f plus g, okay, you want me to take the f function, x cubed plus 5x plus 12, and the g function, 5x squared minus 4x minus 14, and I want you to add them together. That is exactly what we did in the first problem just a second ago. So I would just write out the same thing. I would say, okay, f is this one, okay, if I'm looking up at the reference on the top. Okay, put parentheses around each of them to isolate them from the other one, and they're saying to add g of x. Well, g of x is 5x squared minus 4x minus 14. Okay, I'm not going to do this again because that is the same thing as our first problem that we've already done. Okay, g minus f, well, g is going to be 5x squared minus 4x minus 14, and I'm going to subtract f, which is x cubed plus 5x plus 12. Again, we already did it. That was the second problem on the last slide. And h times g, I'm going to say h is x plus 10 times g, which is 5x squared minus 4x minus 14. Right? So all I'm asking you to do is the same thing, but I'm asking it a little differently. Right? We're asking it with function notation instead of writing out f and g and h every single time. All right, so let's take a look at the formal definition. So I'll let you write this down as you want. What we're basically saying is if I say f plus g in parentheses of x, I just mean add together f of x and g of x. The same thing for multiplies and divides. Okay, this little expression here, g of x cannot be equal to 0. We'll talk about that in the next video, which will be exclusively on dividing. Okay, so this little box at the bottom is the new piece of information for this slide. So what I'm saying is that when we're talking about domain, right, if I have a restriction on the one of the functions. Like let's say, for example, whatever this f function was, I'm saying x is only greater than 0, right? I'm saying just positive numbers in this spot. Whatever new function comes out of f of x plus g of x is also going to have that same restriction. So for my new function, whatever comes out, f of x plus g of x, I'm also going to say x cannot be greater than 0. Okay. If g of x had its own restriction, let's say, for example, g of x said x cannot be less than negative 10. Right? Oh, sorry, x is only less than negative 10. So let's try this again. So if I'm saying this one is only x values greater than 0, and this one I'm saying this is only x values greater than 10, for example. Okay, this one is saying they have to be greater than 0. This one is saying, well, wait a second, I can't use 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't use any of those. It has to start at 10. My new function is going to say, you know what? I have to stick with the greater than 10 because g of x said I'm not allowed to use 1, 2, 3, 4, 5, 6, 7. Right? So even though f of x said that the domain could be things greater than 0, like 1, 2, 3, 4, 5, 6, 7, 8, 9, g of x is saying, you know what, I have my own restriction, x has to be greater than 10, so our answer has to kind of take those two domains and put them together. And that's going to apply to subtraction, multiplication, and division. So you'll see that on our next slide when we go through it. Okay, so let's add together two functions. I'm adding together f of x plus g of x. And so we're just going to say, okay, this is 4x plus 7, okay, plus the square root of x plus x. Okay, so we're just going to combine like terms. I'm going to say this is 4x plus x, which is 5x. Okay, so I'm going to say 4x plus x is 5x. Okay, plus 7 plus the square root of x. I can't combine the square root of x with anything else. Okay, so this is my final answer. I've added together the two expressions, and now I need to talk about the domain of the new expression. Well, my original f, the domain was all real numbers. I can plug in whatever I want for x, and I'm not going to say, oh, this is going to give me an error message or nothing's going to come out of it. When I talk about g of x, though, if I look at my g of x function, I'm going to say, you know what? I can only plug in x values that are greater than or equal to 0. I'm not allowed to plug in negative numbers under a radical and get a real number back, so I'm going to restrict my domain. That means that for my new function, this one right here, I'm going to say the same thing. I'm going to say, you know what? This inherits the domain of g. We're going to say x has to be greater than or equal to 0 for my new expression. Okay. The exact same thing's going to happen for f minus g. I'm going to say it's 4x plus 7 minus the square root of x plus x. Okay. So again, I just have to be careful when I'm subtracting. 4x minus x is 3x plus 7, because that's in the first polynomial, minus the square root of x. Okay, and then the same domain restrictions are going to apply. This is still all real numbers and still greater than or equal to 0. So I'm going to say this new expression also has a domain that x must be greater than or equal to 0. Okay, so the idea is put them together just like you know how. If one of them has any kind of restriction on what you're allowed to input, your answer has that exact same restriction. Okay, so here are some problems. If you'd like to try them and bring them to class, okay, we will do them there. But we're going to move on, and we're going to look at this idea of, does the order that I write them matter? So if, this is basically saying, if I did this and said f plus g of x, is that the same thing as saying g plus f of x? Okay, and the answer to this question is, does this equal, or are these things equal? The answer is yes, they are. Okay, these things are equal to each other because the order that we add things does not matter. Addition is a commutative property, which means we can switch the order. Okay, and when I'm talking about subtraction, I'm going to say in this case f minus g of x is not equal to, right, not equal to g minus f of x. Okay, because the order when you subtract does matter, right? 5 minus 7 is not the same as 7 minus 5. So just be careful when you're doing addition and subtraction. Addition, you're okay. You can do the switch the order. Subtraction, not okay. You have to make sure that you write them in the same order. Okay, the commutative property applies.